We're moving into 6.6. We're talking about direct variation. And direct variation is just a special linear equation. So it looks just like what we've been graphing. It's a line. And it's called direct variation because of one characteristic that every one of these lines shares. And I'm going to show you that in an animation. Okay, so unfortunately the animation isn't working, and I think it's because I declined an invitation to update my Java this morning. But anyway, here is, whoops. I wasn't doing that. Anyway, here is a linear equation that is direct variation. And here is a second one. And here's a third one. And here's a fourth one. And these are all linear equations that are direct variation. And so what do they all have in common, Teddy? They all, he says cross in the middle. How else could you say that, really, Caitlin? They all meet at this point 0, and where is that point? I mean, I guess that's hard to answer. When we look at our slope-intercept form, where does that point 0 show up, Brian? So is it the slope or is it the y-intercept? Where is this crossing the y-axis? This is crossing the y-axis at the y value of 0. So all of these equations cross or have a y-intercept right at 0. And if we have a y-intercept at 0, then we could write it this way. mx plus 0, right? And when we add 0, do we really need to show that? It doesn't change the value of an equation at all, does it? So you could just write this as y equals mx, and that's what we do. These do not have the same slope. I heard a few people saying that. They don't have the same slope. I mean, look at this line that is coming from here to here. That's a positive slope, right? And this line going from here to here is a negative slope. I mean, if they had the same slope, they'd be on top of each other. They all have different slopes, each of these lines. So the slope is right here. It's the m, isn't it? That's the only thing that varies in these equations. The only thing that's different is the slope, because they all have a y-intercept at, where is it? 0. Okay? So when we look at the equation for direct variation, it's written y equals kx. They could have written it y equals mx, right? Because k is the slope. But they choose to say this is kind of a unique situation when you only have, when you have a y-intercept at 0. So they want to kind of highlight that in these equations by naming the slope the k, the constant of variation. Okay? So the slope is k, the y-intercept is 0, and these lines always go through the point of origin like we just saw, or 0, 0. So when you don't see a y-intercept visible in an equation, you know it goes through 0. That's really it. If you know that the point has a y-intercept at 0, and I mean the line does, then you know you have direct variation. So somebody give me a slope, any slope, Cammie. A number. 20. So if we know we have a slope of 20, we can simply write the equation y equals 20x. The y-intercept is at 0. Okay? Give me another number column.
5.
5. So we could write, can you write the equation? If this has a slope or a constant of 5, we would say y equals 5x. Okay? So there's a lot of ways we can work with this. We can look at an equation on a graph. We can look at the graph and see that it goes through 0 as a y-intercept. And all we have to do is find the slope, and we can write the equation. Right? We can also look at this in a table and see if we can find it. So that's what we're going to do. We're going to identify direct variation. So let's tell whether the equation that we're looking at represents direct variation. And direct variation takes this form, y equals kx. This constant, there's only one constant, one number that doesn't change, and that's the slope, k. Okay, so let's look at this equation. This equation is negative 3x plus y equals 9. So right now, is this equation in slope-intercept form?
Good morning, Mrs. Pamela.
The first thing we might want to do is put this in slope-intercept form, right? So solve for y. Okay.
Divide each side by 3.
Are we multiplying y by 3?
Yeah.
No. We need to move everything away from y. Y is kind of just sitting there. How can you move that negative 3x away?
Divide 9 by it.
No. You just need to move it away. We have basically y plus a negative 3x. So what's the inverse of negative 3x? Positive. So positive 3x both sides. Or add 3x to both sides, right? And then we have 0 plus y, which is just y, right? Equals 3x plus 9. So there's our slope-intercept form. Okay? So tell me, what is a slope here? The slope is?
3.
Just the number 3, right? 3 over 1, right? And what is the y-intercept?
9.
Is this direct variation?
No.
No. If it was direct variation, this equation would say y equals 3x, and that's it. We would not see this y-intercept. So not direct variation. Okay? So tell me now, how do we solve for y in this equation here? And is it? Okay, so she says add 3x to both sides of the equal sign. And we end up with y equals 3x. If we wanted to really show slope-intercept form, what would the intercept be when you don't see it? It would be plus 0. So is this direct variation? Yes. This line goes through a y-intercept of 0. That's the starting point. Can we identify direct variation when given a table of points? So you've identified it when given a graph, and you identified it when given an equation that you had to put in slope-intercept form. So now, can you identify it from a table? So we know that if direct variation is y equals kx, then how would we get k alone? Divided by what? What would you do? I mean, what's next to k, Olivia? X. So we're multiplying k times x. So if you want to get k alone, you would divide x from both sides, right? So you could say k equals y over x, right? You could say that. Okay, so here we have a table. And I mean, there's actually another way we could do this, but if we just take y over x, right here, what would y over x look like for this first point, 1, 6? Which one is the y here? 6. So we would say 6 over 1. And then in the second point, we would say, which one is the y in the second point? 12. So we'd say 12 over 2. So is this equal? Is 6 over 1 equal to 12 over 2? Is it? What does 12 over 2 equal? It equals 6 as well, right? And let's try it again with the third point. Who can give me the third point? Jake. 18 over 3. And is that still 6? So what is the constant then? The constant is 6. So is this direct variation?
No. Yes.
Well, let's see if it has a point 0. A second way to look at it. If you Do you notice that there's a pattern in the domain, the x's? And when we go like this, how do we get from 1 to 2? What's the pattern there? So there's +1 here. And is it still +1 here?
Yes.
Okay, so we have +1 and here?
+1.
So we have it all the way, this beautiful pattern. If you have a pattern in your domain like that, the x values, then you can look for a pattern in your range, the y values. And the pattern there is +6, +6, +6, +6, and +6. And so if we have +6 moving to the right, what do we have moving to the left? So we would go -6, -6, -6, minus. So what would we do if we made another little column here? 6 minus 6 is 0. And what would 1 minus 1 be?
0.
So do we have the point 0, 0? We do. We have a y-intercept at 0. So yes, this is direct variation. Okay? We can find the point 0, 0 by going a little step in front of this table. We could try that same thing here. Do we have a pattern in the domain up here? We have +1, right? +1, +1. Do we have a pattern in the range? And what is it? +3, +3, +3. And so could we work our way back to 0? Okay, so we could go back one step again. We could make another little piece in this table, right? And subtract 1 and get to 0 here. And when we subtract 3, do we get to 0? What do we get to? We get to 1. So what is the y-intercept for that equation? Or where is it? Walk 0, fly 1. So this is the y-intercept. It's not at 0, 0. So is this direct variation? No, not direct variation. Okay? We really do have to figure out whether we have point 0, 0, don't we? That's really the indication that we have a direct variation equation. So we might make a note here and kind of star it. Do, or does, let's say does the line have point 0, 0? If yes, we have direct variation. That's huge. So what are you going to think of when you think of direct variation?
0, 0.
0, 0. These are lines that cross 0, 0. There you go. Plenty of time in here, so be really careful, workers.